Okay, welcome back, you guys. Happy New Year. We're in the middle of chapter 4. We're on section 4.4, modeling and optimization. Your objectives is solve application problems involving finding minimum or maximum values of a function. So we have our strategies we have to go through, which is pretty much the same as doing any kind of word problem. Strategies for solving max-min problems, you need to obviously understand the problem, read it very carefully, and identify the information that you need to be able to solve this problem. Develop a mathematical model of the problem, a picture, draw a picture, label parts that are important to the problem, introduce a variable to represent quantities that needs to be max or min. Use that variable to write a function. Graph it, find the domain of the function. It's important to know basically what values you can use. Identify the critical points and endpoints. Don't forget to use endpoints. And find where the derivative is 0 or fails to exist. Solve the problem and then interpret it. In the AP test, you will need to be able to interpret your findings. You can't just say, oh, the answer is 10. Well, what does 10 mean? You have to basically keep this in mind, kind of like writing a paper. You'd write a paper and you give them information, assuming the reader has no clue what you're talking about. Same thing with mathematical problems, and as such, is that you need to write things out as if the person who's looking at your work has no clue what the problem was or how to do it. Okay, so the fairly simple one here to start out with, using the strategy, find two numbers whose sum is 20 and whose product is as large as possible. Well, whenever they give you this product needs to be as large as possible, you've got to think derivative. Okay, so we're going to start with the sum, which means we have two variables. X plus some y value has to equal 20. But we also want their product to be as large as possible. So x times y. And we really need this to be a maximum value. So this is what we need to maximize, but we don't really want to play with two variables. So I'm going to rewrite, just so it's easy for us, rewrite this guy in terms of x. Anyways, y equals. So this guy here is going to be y equals 20 minus x, because now I can replace this y value for this guy, and I get x times 20 minus x needs to be that maximum value. Well, to maximize or minimize a value, this is where the derivative comes into play. So I'm going to go ahead and clean this up so I don't have to use product rule. So this gives me 20x minus x squared. And I need this to be a maximum value. So what we do is the derivative, take the derivative. So we get 20 minus 2x. And to get the maximum value, we need that to be equal to 0. So we have 20 minus 2x equals 0. Let's come up here. So I'm going to move the 2x to the other side. So I get 20 equals 2x. Divide both sides by 2, and we get x equals 10. And if x equals 10, then we can go back to find out y. Y is going to be 20 minus 10, so y also is equal to 10. So the two numbers with the sum of 20, the largest product. So the two numbers with a sum of 20 and a maximum product is 10 and 10. Now, for those of you, and I have students that they'll calculate this very, very quickly without calculus, and it's because you guys have been taught that the largest area is going to come from a square? Well, guess what? 10 squared is 100, and 10 plus 10 is 20. So if you can get a perfect square, that's going to give you a maximum value. But what if they said, I want the maximum value to be 19? Okay, so now at that point, you're looking at not getting really nice numbers because you're not going to get a square out of that. Well, I suppose you can, but you know what I mean. All right, so that was more along the lines of a simpler version of types of problems you'll see. Here's another kind of problems. A rectangle is to be inscribed under one arch of the sine curve. What is the largest area the rectangle can have, and what dimensions give that area? Now, they drew the picture for you, so you only need to use the picture to come up with a model. Now, they are telling you that this is starting at 0 and it's going to pi, so you don't even have to guess on that. So you know that your value is somewhere less than 3.14. And you know that's more than half pi because of the picture here. Now, what we need to look at is whenever they give you this, we need to go with, well, from here to here is some x value. Now keep in mind that this being a rectangle, this value has to have the same height as this guy. And the curve here is sine of x, so this point P is going to be x sine of x. Okay, so anyways, this value here, the length here, is whatever sine of x is. The problem is, though, is that we need this length here. So a couple of things that you have to know, and this comes into geometry, a lot of geometry here. We know that the height of a rectangle must be the same on both sides. That's just a definition of a rectangle. Sides, the opposite sides are congruent and parallel. So we know that whatever the value of this P, y value of P, the same y value over here happens for Q. But our x values are not the same. But we do know that the sine value or the sine wave is very symmetric. So you get pi over 4 and 3 pi over 4, you get the same y value out of it. So we can also claim that this is x as well. And this is just coming from symmetry. That to get the same height here from 0 in has to be the same as from pi in as well. These two values have to be the same. And we know the whole length here is pi, so the length of my rectangle is pi minus 2x. So we now have a y value and an x value, even though x is in there. And they're asking us to find the largest area for this rectangle. So for rectangle, area is equal to length times width, or you can go base times height. Since we're looking at it, we can count this as base and this is the height. So I know that my base is equal to sine of x, and I'm sorry, that's the height. My height is equal to sine of x, and the base is equal to pi minus 2x. And area is equal to the base times height, or length times width, so it's going to be sine of x times pi minus 2x. Now, from this point, they were wanting us to ask for the largest area, so they're asking us to maximize this. On this particular one, it doesn't matter which way you approach this, you're going to have to use the product rule. If you distribute sine of x, you'll still have to use a product rule because you have 2x times sine of x. So I'm just going to go ahead and go with the product rule here. So u is going to be sine of x, so u prime would be cosine of x. V is equal to pi minus 2x, so v prime is equal to negative 2. Reminder, pi is a constant, derivative constant is 0, minus 2 times the x value, and the derivative of x is 1. Don't forget this is u prime v plus v prime u. So our area prime, is going to be cosine of x times this. So cosine of x times pi minus 2x. Because of this minus, it's going to become minus 2 sine of x. Now, we can play with this problem a whole lot more, but you might as well just throw this into the calculator and go from there. We're still trying to find the sine of the value of x. Well, to maximize this, we would take our derivative and set it equal to 0. So we have cosine of x times pi minus 2x minus 2 sine of x equal to 0. And what you're going to do at this point is you're going to grab your handy-dandy calculator and you're going to graph this thing. So make sure your calculator is in radian mode. And then you're going to graph it. So cosine of x, close parentheses, start new parentheses for the pi minus 2x, close parentheses, minus 2 sine of x. And then go ahead and do a zoom 7. Let your calculator know that you are graphing trig. So do a zoom 7. It's going to give you more information than you need, but what we can do from there is keep in mind of it. Once it graphs, set your window 0 to pi, because that's the only part of the picture we want. X min is going to be 0, X max is going to be pi. And it looks like that they broke this up into pi over 4. So pi divided by 4. And as you can see, we want a value that is going to be before half a pi. Okay, so why do I say that? Because we're looking for this x value right here. This guy. Whatever, we don't care what this number is over here. It's this guy that we want. And so what we're going to do is we want this guy. So when we grab the calculator, by the way, after you put in your stuff, you can hit graph. We look at your calculator compared to, this is why I went ahead and scaled it by pi over 4. This is pi over 4, 2 pi over 4, or 1/2, 3 pi over 4, 4 pi over 4, or pi. I want the value that's going to come just before that pi over 4 here. And so, because you guys, you can see it hits it twice. So, and what you need to do is just tell the calculator to give you a value there. So, second calc, and we want to know the 0, so hit 2 for 0. And you want to left bound, you know that that's pi over 4, so grab a number prior to pi over 4, like pi over 6. So pi divided by 6 for the left bound. The right bound, make it pi over 3. We just want something between there. So pi divided by 3. And your calculator will give you, so you're saying somewhere in here. Yes, I am, somewhere in there. And hit enter again, and it gives you an answer of 0.7104. So x is equal to 0.71046274. Those are all the values my calculator gave me. Now, keep in mind, let's go back. It says, what is the largest area the rectangle can have, and what dimensions give that area? So, you've got the x value, because remember, we're going the length times width. So x value, that is not part of the dimensions. So we want to know what pi minus 2x equals, and we want to know what sine of x equals. So if I put this in you have to use a calculator, you guys. There's no way to do this without a calculator. So I go back to my main screen and I do pi minus 2 times, so parentheses, 0.71046.274 gives me a value of 1.720667174. And if I do sine of x, I get 0.6521846256. And these are my dimensions. There's my dimensions. And the area from these two dimensions, so multiply the two together. So if you just hit times, it'll grab your last answer and arrow up to the first one, the 1.72. I get 1.1221, and more numbers come behind it. But in calculus, you only have to be correct to the first three digits. And this is going to be units squared. We don't know what the units are, so units squared. So our dimensions on this thing is 1.7206 times 0.65218. Multiply them together, we get 1.1221. And we've answered the question. Make sure you answer everything. Identify the dimensions, identify the area. So there you guys go on that particular one. So I believe we got one more, 16 minutes into the video, so one more. Inscribing rectangles on this particular one, a rectangle is inscribed in an isosceles right triangle. This is important information. Isosceles right triangle where the hypotenuse is 2 units long. First thing they want you to do, express the y-coordinate of P in terms of x. Hint, write an equation for the line A to B. Part 2, or B, express the area of the rectangle in terms of x. What is the largest area the rectangle can have, and what are its dimensions? So they kind of broke this one up more for you, but you got the same idea going on. Now, they did tell you this is an isosceles right triangle. And from here to here is 2, so these are my base angles of my isosceles right triangle. That means this guy up here is my right triangle. Now, here's a reminder. If you have an isosceles right triangle, then these two angles are congruent, which means these two sides are congruent, which means that this rectangle in here, because definition of a rectangle, the sides are congruent and parallel, tells me that half the rectangle is on this side, the other half's on this side. Now, I know my picture is not perfect, but we're going to go with it. So let's just talk about one side. If I throw a perpendicular bisector in here, then because this is an isosceles right triangle, it will break it up into 2 more isosceles right triangles, making now this a 45-degree angle and this one down here as 90. And if this guy, anyway, I should say if this guy is 45 and this guy is 45, then this length and this length is the same. Well, this point is 1, so I have a point here of 1, 0. And if these two are the same, then these two must be the same, which means my point B is 0, 1. We have 2 points. We can come to that equation of the line. So we're still working on part A. We had a lot to do in here with that part A, a lot of geometry. But we can find our slope now because we have 2 points. Slope is y2 minus y1 over x2 minus x1. Well, our points are 0, 1, and 1, 0. So we get 0 minus 1 over 1 minus 0 gives us negative 1 over 1, or negative 1. There's my slope. My y-intercept is, which is B, is 1. You guys, it's right here. So in part A, my y value for that point is 1 minus x. Y-intercept is 1, slope is negative 1, so write it backwards. There. Part A is done. Part B asks us to write the expression of the rectangle in terms of x, area. Now we're talking this one. So if I look at this side alone, I have the length being x and the width being 1 minus x. This being the length, this being the width. Because we had already decided what the equation of this line is. So the area, now you guys, I only did it for the one side, and these two are, we decided earlier that they're exactly the same because it's an isosceles right triangle by definition of an isosceles right triangle, and by definition of a rectangle, we know that as we start breaking these apart, that half is on each side of the equation. So I actually have 2 times x times 1 minus x. There's the area of our triangle in terms of x. Part B, done. Now we can express this a little bit differently by writing it as 2x minus 2x squared. There's the E. And then part C asks us to what is the largest area the rectangle can have and what are its dimensions. Okay, well, if the area is equal to 2x minus 2x squared, and we want to maximize this, that means we have to do a derivative. So A prime is 2 minus 4x. And to complete this, we set our area equal to 0. So 2 minus 4x equals 0. Move the 4x to the other side. We get 2 equals 4x. Divide by 4. And we get x equals 1/2. Now remember, x is only going from 0 to 1. So x equals 1/2. But keep in mind up here that because there's 2 rectangles, we had to double that up. So our dimensions, well, the length is going to be 2 times x, which is 2 times 1/2, which gives us 1. And our width is going to be 1 minus x, which is 1 minus 1/2, which is equal to 1/2. So the largest area, the maximum area, is 1 times 1/2, or 1/2 units squared. And there we are. This is all of your answer to part C, because they ask you for dimensions and area. Now, keep in mind, and maybe I should have wrote it up here, this was for one rectangle, 1 or 1/2 of the rectangle. So that's where the 2x came over here. Because this is x, but this over here is x as well. But I don't want you guys going, well, why don't we double up the height or the width? That didn't change at all. It doesn't matter what. It went from here to here. But I was only playing with half of it to get it my answer. Okay, we're going to stop the video here. 23 minutes is kind of a long video, so I'm going to stop it here. And if we don't cover things in class, then you guys will be finishing up the video on your own. Good luck.